Hello everyone, this is Nilesh Gule. Welcomes you to Object-Oriented Analysis and Design class. You can be object-oriented programmer using C++, Java, C Sharp, or for that sake, JavaScript or Python too. And you keep talking about the terminologies like class, object, inheritance, composition, polymorphism, so on and so forth. But given a problem statement, how do you really decide which classes to be written, how to relate them, how to create the objects? This particular stuff is definitely called as object-oriented thought process, or many times referred as object-oriented analysis and design. Now, when it comes to the word OOP, lot of people have a lot of different opinions. And I personally do not want to add my opinions into that. Instead, I thought of going back to the source and bring some more authentic terms from OOP for you people. Have you ever heard the name Grady Booch? The Grady Booch is said to be the father of modern object-oriented analysis and design. He has written a wonderful book, Object-Oriented Analysis and Design. And I always recommend this particular book to all my students. If you get time, I strongly recommend that please go back and read that book. In this particular video, I'm going to present a very basic level ideas from that particular book, and I'm going to keep it bit simple and more practical stuff. Object-oriented programming is one of the most commonly asked interview question, irrespective of whether you are absolute beginner or you are experienced one. So it is worth learning OOP once and for all in your life. In this particular class, we are going to talk about the same object-oriented analysis and design ideas. According to the Grady Booch, the object-oriented programming concept are divided into major pillars and minor pillars. If any language want to call itself as an object-oriented language, it must have all the major pillars, while minor pillars are the optional pillars that object-oriented languages support, and the languages said to be fully object-oriented languages, they definitely support these minor pillars. These concepts, let me name them one by one. The major pillar is abstraction, encapsulation, hierarchy, and modularity, while minor pillars are typing, concurrency, and persistence. I'm very sure you might be confused that some of the well-known terms like inheritance, composition, or polymorphism are missing from the list. Hold on. As we will go ahead, we will talk about all these terminologies at the right place. By the way, object-oriented thought process is more or less conceptual discussion. But to keep it relevant, I thought of adding some code snippet examples. Ideally, you can learn OOP using any object-oriented language. As far as this video is concerned, I'm going to talk about C# code snippets. And I'm very sure you can very well relate to any other object-oriented language that you are working with. So let us begin with the first major pillar, that is abstraction. So what is abstraction? The abstraction is all about getting essential details of the system while hiding the internal implementation details. You are using the remote control all the time. So in remote control, all we are doing is pressing some buttons on that device without even understanding what kind of electronic circuit is running behind the scene. We hardly bother whether we are using a remote which is running on radio frequencies or it is working on infrared frequencies. But who cares? It is all about pressing buttons and get the work done. So this is nothing but you can understand abstraction. So another example you can talk about, let's say a car. So being a driver, all you worry about the press the pedal and increase the speed. So hit the brake and then stop the car. But do you really bother about how exactly the whole car mechanics work behind the scene? And we don't care. That is the beauty of the abstraction. Abstraction makes you use the things easily without understanding its complexity. It manages the complexity for you. It simplifies the interaction with such complicated system, and most importantly, it defines the outer layer or outer view of the system. You can see the system as a black box and you only understand how to interact with that particular system. Another very important point to understand, the abstraction always depends on the perspective of the user. When the user change or when the perspective change, you can see the same system in a different manner. I was talking about the example of a car. Being a driver, I hardly care about pressing the pedal to increase and decrease the speed. But if you are a car mechanic, which is another user of the same system, now he has to understand the throttle body, injectors, ECU signal, and all the mechanics behind it. If you are the car designer or engineer, you have to again think little separately for the same abstraction. Let us talk about how this abstraction can be achieved in the programming languages. There are two major ways to implement in almost all programming languages. One is abstract class and another is the interfaces. The abstract class can provide you little implementations, leaving the other parts abstract, while interfaces are like contract. They specify what needs to be done, but they do not provide any kind of implementation. We can also consider interfaces as pure abstraction. Here is one simple C# example of the abstract class. You can see an example. We talk about having a simple abstract vehicle class, and it is having two methods like start engine and get fuel level, which are abstract method. But at the same time, this particular class may have some data member. This particular class may have some other methods implemented like display fuel level. But another method of doing the same thing is interfaces. You can see the example of an interface over here. An interface keep talking about what can be done. So here, one of the example I have given is a simple database connection. So for any simple database connection, the basic idea is to connect to the database and disconnect from the database. To check whether it is connected or not connected, a simple getter method. In this interface, you never realize what entirely logic is written behind the scene for the connection or disconnection. It is only telling me what is supposed to be done, but not exactly how it is to be done. What you can do is you can go ahead, you can write your own class, and that class can be inherited from the database connection. And depending on your database, depending on your mode of connection, you can actually implement that interface. Now, one who is going to use your class, one especially your colleague who is supposed to use your implementation. So he will simply create an object and call the methods given in the interface. He will not really bother about how exactly you are connecting to the database or how you are disconnecting it from the database. There is another example of abstract class that you can watch over here. So these are the examples given in C#. You can definitely write the similar examples into Java, C++, or other languages as per your choice. Now that you have understood about the abstraction, it's time to talk about the next major pillar, that is encapsulation. The encapsulation is about bundling your data and methods together and providing controlled access to the data. Encapsulation word might have come from the medical capsule. If you ever open that medical capsule, there is a lot of bitter medicines inside it. Just putting these medicines into a wrapper make it very easy to swallow. So encapsulation talks about the internal arrangement. Encapsulation talks about the internal mechanism, while Abstraction was only giving you the outer view. You can say that encapsulation and abstraction, they are complementary to each other. If there is no encapsulation, your data will be accessible to anyone directly. And if it is accessible directly, someone might set the wrong values over there. Let me show you a simple example over here. You can see a very simple bank account class with a data balance, and you can note it. I have done it public. Also, I have written a deposit method and I'm putting some amount without any kind of validation. Now, what might go wrong when someone is using your class? When I say someone, I'm talking about your teammate or your colleague who is using your class. Don't you think that since he has got access to your account balance, he might by mistake set the balance entirely wrong? So having minus 1000 balance is absolute nonsense. Or someone trying to deposit the amount, let's say minus 500, which is totally nonsense. Now, these problems will definitely lead unexpected, undesired results. And this is where encapsulation comes into picture. Encapsulation prevents the unauthorized access to the sensitive data, and it maintains the object integrity through proper validation. And this defines the inner design of your system. Now, let me give you the example how exactly encapsulation manage it. So, typical encapsulation example could be setting up your data or some of the internal implementation as private. Now, you know that any members which are declared private, they are accessible only inside the class. They cannot be accessed from outside. If you want to make it accessible outside, you will write some wrapper methods for them. In the languages like C++, Java, you can typically write the getter setter methods with a proper validation. In C Sharp, usually we recommend writing the properties for that. And the properties having the get and set part, which is doing exactly same job. Typically, this encapsulation is handled with putting appropriate access specifiers. So you see that the data members are usually private and your member functions or your getter setter properties, they are usually public. But there are other access specifier too, like public, private, protected, internal, and so on. They may change a little bit from language to language. As far as this access is concerned to the data members, they are given via getter, setter. And the person who is writing the class, he has got the full freedom to decide which data members I should provide getter, setter. For which data member I should provide only getter, for which data member I should provide only setter. Not only that, while setting the value, it is very standard practice that you always verify that not the wrong value is set into your data. If anyone try to set the wrong value even by mistake, it should throw the exception. And similar stuff, you can also check it inside your each public method. So you can have the proper validation which ensure that your object state will never go wrong. Now that you talked about abstraction and encapsulation, it's time to move on to the next major pillar, and that is nothing but hierarchy. Oh yes, you were waiting for the words like inheritance or composition. Let me talk about the Grady Booch talks about the more generic word hierarchy. The hierarchy can be is a hierarchy or has a hierarchy. There are other types of hierarchy as well, but for this video, let us focus on is a and has a hierarchy. Typically, is a hierarchy, we call it as inheritance, and has a hierarchy, we usually talk about the composition or association. Let me talk about the inheritance. The inheritance is typically the parent-child relationship between the classes. So you consider a simple example. like dog is an animal, or for that sake, you can have like a mango is a fruit or fruit is a food. You can have a single level, you can have multiple levels of inheritance. To consider inheritance like the parent properties, parent characteristics are inherited to the child, while child can also have its own characteristics. In the real world, you may not always find that all properties of parent are inherited to the child, but typical OOP languages, yes, all properties, all data, all functions of the parent, they are inherited to the child, and child can do the further specialization, can have its own data as well as it can have its own function too. The people are always worried, how do I decide whether I need inheritance or not? Answer is very simple. Just put it in English. Just check it whether it conforms to either or kind of clause. Like as I was talking about, the dog is an animal. As you understand dog is an animal, you are in other words saying that animal is parent while dog is child. And here is a C-sharp example in front of you. This C-sharp example is writing one simple animal class. The animal class is having some data like name and age, and it is also having some method like make sound. But since it is an animal which can have any generic sound, I have written a simple right line statement accordingly. But when I talk about a dog, the dog now will definitely have name and age, no worries on that. But dog will have some extra special member, maybe breed, and the dog can have some extra functionality like fetch, where a dog can fetch a ball for you. But now you understand that certain functionality which was given into the parent class, certain functionality which was given into the base class, you can also override that functionality. You can also modify that functionality for the derived class. And that is typically done by redefining the method in the derived class. This is technically called as a method overriding, which you see that the method is overridden by the name make sound. And though the animal can have any generic sound, the dog, yes, it barks. So this is a very basic level example of inheritance. As we had already seen about the C sharp, there we have talked about inheritance syntax in much more detail. In this particular video, I am focusing onto the basic OOAD concept with the little example. For more details on inheritance syntax and other stuff, I strongly recommend going back to our C sharp tutorial video and watching it. By the way, why we need inheritance? Yes, inheritance, we need it for basically code reusability and avoiding the duplication. The inheritance is natural modeling of the real world relationship. As I said that the fruit is a food or mango is a fruit that you can put it into the programming code, writing the separate classes and doing inheritance for that. And over here, when I was talking about the method written into the base class can be redefined with the modified behavior. Yes, this is something you call it as polymorphism. So polymorphism is usually people talk about a separate pillar of OOP, but polymorphism is very well understood into the inheritance itself. In fact, many times the inheritance is done to get this polymorphic behavior. Officially, the word polymorphism, poly means many, morphism means taking form. So polymorphism is all about taking many forms. And more programming language, you can say that you can have the multiple methods with the same name. As you have multiple methods with the same name, the appropriate method will be called at runtime depending on type of object. So as we have even seen during our inheritance class, that if you at all create one dog object with some of the data initialized and you make a call to make sound, what will happen? Now, since the dog object is created and referred by a dot make sound will always call this particular dog class method. It will not call the animal class method. The method is always called depending on type of object. That is nothing but simple polymorphism. Well, there is also compile time polymorphism where you talk about having multiple methods in the same class with the same name but with the different signatures, where the method is called decided by the compiler depending on the type of arguments. Yes, this particular feature is available, but this feature is not available in every object-oriented language like Python. So let us not go into the details of it in this particular video. By the way, we were talking about inheritance. When you talk about inheritance, typically inheritance has got different types. A single inheritance where you are like a one parent class, one child class. You can have a hierarchical inheritance where one base class and multiple child classes. Like you have a person and from person we have inherited student or we have inherited employee. Or you can have multi-level inheritance where from person you inherited employee, from employee you inherit manager. That could be example. And there is also one OOP term called as a multiple inheritance. What is multiple inheritance? Where we have multiple base classes and a single derived class. However, this multiple inheritance is not supported in the languages like Java and C#. Yes, they are supported in the languages like C++, and also that is causing something called as a diamond problem. You can watch about diamond problem in our some other video. Though C# Java doesn't support multiple classes inheritance, yes, they still support multiple interface inheritance. So you can have one class inherited from multiple base interfaces. Like for example, you can have a full stack developer class inherited from backend developer interface as well as front-end developer interface. You see that inheritance is commonly done with abstract classes or interfaces. We already talked about it during abstraction. Abstract classes you can consider like partially built houses. They have some structure already and then you can refine the structure in the derived classes. While interfaces are purely blueprint, no implementation is there. It just talk about what is to be built. When you start, you have to start with a fresh class and you have to implement, you have to build everything that is mentioned into that blueprint. It is very common trend to use abstract classes for easier relationship, while interfaces talk about can-do relationship. If you are C# or Java developer, then you might have seen the interface named as clonable or serializable, which talks about the abilities added into your class with that interface contract. I guess this gives you the brief idea about the inheritance. But as I said, hierarchy is not all about is a relationship. Hierarchy also talk about has a relationship. And sometimes the has a relationship is preferred over is a relationship, especially to avoid that diamond problem. You can consider one of the simple example of a has a hierarchy, like computer has a motherboard has a processor. This has a hierarchy is suitable in certain cases than the inheritance. Like the example given over here, the car has an engine, car has a radio. You do not go for inheritance for two reasons. Number one, it doesn't fit with the is a relationship. You see that you never say that car is a engine or car is a radio. You always say that car has a engine and car has a radio. Yes, that has a relationship is perfect. Also, if you have the similar methods in the base classes and you inherit it in the derived class, at that time, this can always cause the ambiguity problem. This can always cause the multiple inheritance diamond problem. So, in such situation, having as a relationship is a better idea. In one of my video, I have discussed in detail about the association, composition, and aggregation. Let me tell you in very simple word. The association talks about a general relationship between two objects where they are not tightly coupled with each other. Their lifetime doesn't depend on each other. A simple example could be car has a driver. Now, car and driver can definitely remain without each other independently. Then comes aggregation. Aggregation represent weak ownership. Take a simple example. Let's say car has wheels. Now, the wheels in the car are, though part of a car, they are very easily replaceable. So you can take one wheel out and fit another in place very easily. So here has a relationship is showing a weak ownership, that is aggregation. And then another example where you have like a tight relationship, the tight coupling, like car has an engine. The engine is very much integral part of the car and not so easily replaceable from the car. So in that way, it is a complete part of relationship where you can call it as composition. In this typical example, I have talked about something called as an engine and radio class with some very basic level methods. And then I have written a car class. In that car, we have two objects composed like engine and radio. And when we start the car, I'm intending to start engine as well as radio. When I stop the car, I'm intending to stop the engine as well as radio. I hope this clears the concept of composition or has a relationship. For more detailed actual practical demonstration, please watch our composition video. Let us move on to the next. The next interesting pillar is modularity. When we are developing a huge software, are we really putting all the things into one particular class? Which is really bad idea. Many times people or beginners keep doing that mistake, writing all the functionality into one class like a god class which can do everything. It can be a good approach for the very basic beginner level stuff, but it is really unmaintainable, unreadable solution. So it is always recommended that you break your big application into independent interchangeable modules. Like you talk about car has got different modules like engine, transmission, brake, gear system, and so on and so forth. And putting it all these things together, you make a car which is fully functional while each component is doing its own work while interacting with each other. The basic idea behind modularity is to divide the work into the different modules as per their functionality. And these modules at runtime, they should come together and work as a single unit. You want to keep the interaction between the modules minimal, and inside the module, they should be working tightly with each other. Why you need this? As I said, I want to write a software which is really huge. So of course, this whole huge software cannot be developed with one person. You need the team of developers. And if you need the team of the developer, you have to divide your code into multiple pieces. And then each developer can work together and collaborate. Also, you want to make certain code snippet which can be used with the multiple different projects. You want to make it reusable. And of course, this has to make your application maintainable. The bug finding and bug fixing will always become easy with the modularity. The question is how this modularity is achieved. Now, typically, the different languages have different terms. Like C++ or C Sharp, we have terminology called as a namespaces, while Java has got terminology called as a packages. Is one of the way of achieving the modularity. There are other modularity options also available. Let us first talk about the namespaces, the very basic idea. Suppose I want to write some typical web-based application where you need some sort of backend data access, you want some business logic, and then you want some front end where you want to serve that data to your client. So instead of putting all that functionality into one class or even into the multiple classes, you can logically divide it into the namespaces. Like I can have one namespace for data access, and this data access namespace will have all database related interfaces, database related classes, and so on and so forth. The another one, we can have another namespace like business logic, where we will have all my business logic work. And in this business logic work, if you need the access to the database, you can access it via the interfaces. Typically, you will find that these components which are separated, maybe into the namespaces or modules, they usually are connected well with each other via the interfaces, via the interface contracts that you can see over here. On the similar line, you can have some front-end controller component which can access your business logic component. Well, you understood that namespaces is one of the way of doing modularity in C Sharp. But what are other ways? In C Sharp, in .NET, there is a typical class libraries where you can physically divide your classes into the libraries, typically with the extension DLL, dynamic link libraries. And then whenever any particular executable is trying to access these classes, these DLLs will be runtime attached to that particular classes and will execute it. My earlier .NET videos discussing the .NET architecture, I have discussed in detail about the class libraries, DLLs, and how they work together. In C Sharp specifically, there is another special feature called as a partial classes. The partial classes is one of the innovative feature available only in C Sharp, where your one class, you can divide it into the multiple parts. The half of the function you can write it in one file, half of the functions you can write it in another file. And you might be worried where this functionality can be useful. But this can be useful for making your commonly required code readable, while some auto-generated code or some very complex logic can be hidden into other files. Typically, C# GUI programming, Windows form programming, you will find that the class is divided into the two parts. That is also a level of modularity. We will talk about the partial classes and partial methods in some other video. And as I said that this is modularity, but this modularity typically works with something called as interfaces, and many times you want option that the implementations can be plugged in as and when required. So at runtime, you might be using the database connection from Oracle, or you might be using database connection from the MySQL. But then ideally they should work well without any trouble. And this particular feature is referred as dependency injection. Well, we will have a detailed discussion on dependency injection somewhere in other video. Now you have understood that there are four major pillars. What is abstraction, encapsulation, hierarchy, and modularity. And these are the major pillars. When I talked about hierarchy, I talked about inheritance, and I told you polymorphism is very much part of it. In a real software, all these four major components, they work hand in hand. Consider a simple banking system. In a banking system, you have a bank account class, and this bank account class can have some balance, some account holder information, some of the deposit withdraw kind of functionality, and so many different things. But the abstraction is hiding all that complex details and providing you some simple interface, allowing you to deposit some amount or withdraw the amount. Correct? Then comes encapsulation, which is ensuring that your critical data is kept private. No one should be able to access it directly, and no wrong state should be stored in it. The appropriate validations will be always done. Then there is a hierarchy. You consider you can have the saving account, current account. These are the types of account where you can talk about easier relationship. And then the modularity, where you can have the separate modules talking about the account management, or the separate module for the transaction, or the separate module for the report generations. If you are a beginner in object-oriented world, some of the common mistakes that you should avoid into these pillars. First one is abstraction, where you are exposing the implementation details. You do not create only the bank account class. I strongly recommend you create an interface, and with interface, you write the method deposit and withdraw so that your users will only able to access the relevant methods without knowing the actual details in background. Then comes encapsulation. Please never make your data, the crucial data, as a public data. You keep your data as private and always provide the access via proper validation. As you've seen in earlier example, balance should never be negative. If anyone is trying to set it, you should throw the exception. Then you talk about the hierarchy. If you are a beginner, there are likely chances that for every problem, you always look for inheritance. But please note that inheritance is not the always solution. You might want to go for the inheritance, you might want to go for composition. Check what really fits either or hazard. Using a very long chain of either relationship is not considered to be very good practice. And then modularity. As I was talking about, putting all functionality into one God class, which is really bad idea. You need to put it into the different classes with the single responsibility principle. Of course, we will talk about this in more detail into the upcoming video. Now that we have discussed about the major pillar, let me give a very brief introduction to the minor pillars as well. As I said that these minor pillars may not be supported in all OOP languages. The first pillar is typing. The typing is related to the data types. So there are typically people talk about the static typing or dynamic typing. Whether your data types are known at the compile time or your data types are understood only at the runtime. You know the languages like C++ or Java, they talk about the static typing, while the languages like Python, they talk about the dynamic typing. What about C Sharp? The C Sharp is static typing. So types are known at the compile time. But with the .NET 4.0, we also have a feature called as a dynamic language runtime, which add the dynamic typing feature in C Sharp. We will discuss about the DLR in a separate video. The typing sometimes also talked in a context of weak typing or strong typing. So you know the language like C, where you can convert a boolean to integer and vice versa without any problem. But The language like Java, you find that it is strongly typed language. You cannot interchange like Boolean to integer so easily. So you find that the C# is also strongly typed language. Apart from that, the typing is also related to the type safety. Typically, when you deal in a collection, you realize that in a collection of student, you want to add only student. By mistake, you do not want to add some string or some employee in that. How do you ensure that? And that is the reason these OOP languages typically come with the type safety generics, or which is sometimes also called as the templates feature. The next feature is concurrency. Concurrency is having multiple tasks, multiple threads running simultaneously within a single application. So when a particular object is accessed by multiple threads at the same time, how exactly it will behave? Will it produce the correct results, or will your results get corrupted? This particular stuff is studied under concurrency. So in concurrency, typically we have the multi-threading features, we have synchronization features, and yes, the prime languages like Java, C#, they support concurrency very well. The next one is persistence. Persistence is about storing the state of the object so that you can reproduce that object later even after the scope of the object is completed. So where exactly you can store the state of the object? The usual options are storing that state into a file or storing that state into the database. So there is a relevant term, serialization. The serialization is converting object into a serial, into a sequence of bytes. And that sequence of bytes, it could be a textual JSON kind of format, or it could be a binary byte format where you can store it into the file, or you might transfer it over the wire, over the network. Also, when you are storing the object state into the database, so there is a typical feature called as ORM, Object Relational Mapping, which is storing your data into the RDBMS and then retrieving it back. As we will progress ahead with this .NET tutorial, I will show you demo of the serialization as well as ORM. Now we've seen a big picture of the major pillars, minor pillars. So does it end of object-oriented thought process? So to be frank, we earlier talked about object-oriented programming as a syntax. In this particular class, I was talking about the object-oriented analysis and design. We talked about the major and kind of minor pillars. This object-oriented thought process will tell you what classes to write, what interfaces to write, how to create the relationships, and etc. etc. However, whatever application that you are writing, are you really building it well? Are you thinking in the right direction? And that is actually understood by the next very important concept called as the solid principles. So in the upcoming video, we will talk about the solid principle. This session was more of conceptual because it was object-oriented thought process. But in the solid principle session, we will take one case study and we will try to apply all these concepts, OOP, OOD, and we will try to implement the classes, interfaces, and everything in a right method, that is solid principle. Now, while implementing these object-oriented applications, we will come across some common problems. And for these common problems, there are well-known solutions available called as design pattern. In upcoming sessions, we will also talk about the design pattern. So stay tuned for the next very important class about solid principles as well as design pattern. Thank you very much for watching so patiently. See you in the next session. Bye-bye.